This is take 2 of this video, so I'm going to explain how I got to this point and minimize the circuit. Remember, we always go from the furthest point towards the source, minimizing the circuit. So the first thing we see is 4K in parallel with 3.5K at an angle of -90. Remember, these have to be in parentheses, especially the ones with the angle, because otherwise you will just get the reciprocal of the angle. When we put these two in parallel, we get 2.634 k ohms at an angle of -4881. We redraw the circuit, but we put a box here because there are different components here. So now when we redrew it, this 8K, this, and this are all in series, so they would share the same current. So we have to add them up. So 8K plus 2.64 at that angle plus 500 at 90 gives us 9.640 k ohms at an angle of -79.63. Then we take this and we redraw the circuit for the last time. Okay, we have this here. We put that here. What's constant in parallel circuit is the voltage. So we need to make sure that this current and this current is correct by getting the I total. So we have to get Z total. So when we get Z total, we put 3.5 k ohms in parallel with 9.640 k ohms at an angle of -79.63. When we do that parallel combination, your I total is 3.115 k ohms at an angle of -18.53. Now we can get I total. I total is just E total, which is 25 at 10, divided by your Z total of 3.115 k ohms at -18.53. When you do that, your I total is 8.03 milliamps at an angle of 28.53. So now we know that we have I total coming in of 8.03 milliamps at an angle of 28.53. So that helps us determine if these two currents are correct, because in a parallel circuit, voltage is constant, but current is additive. So this current and this current must add up to the I total. So to get these two currents, it's 25 at 10 divided by 3.5 k ohms. So let's put that in our calculator. 25 at an angle of 10 divided by 3.5 k ohms. And I got 7.14 milliamps at an angle of 10. So that's the current for this 3.5. I'm going to do the same with this. 25 at an angle of 10 divided by 9.640 K at an angle of -79.63. And I got 2.59 milliamps, so 2.59 milliamps at an angle of 89.63. How do we make sure we didn't fat finger or get something wrong? Is we have to add this plus this and make sure that it adds up to that. Once it does, then we can move up to the circuit. So 7.14 milliamps at an angle of 10 plus 2.59 milliamps at an angle of 89.63 equals 8.0215 milliamps at 28.52. close enough. Unless we use every single number every single time, it's going to be a little off. So that's okay. So basically these two match this, so we're good. So the reason why we note these things here and what we've done is because now we know this is the voltage across this. This is the current through this. How did we get this? We did the series combination. So what's constant in a series circuit? Current. So this current is going to go back here, here, and here, which is right here. So these three will share the current. Then we have to get their individual voltages. And their individual voltages must add up to 25 at 10. So let's bring that. So we're going to multiply all of these by 2.59 milliamps at an angle of 89.63. So that's the current for this guy, this guy, and this guy. And let's get their voltages by multiplying current times this, current times this, and current times this. And then we have to make sure their voltages add up to where it came from, which is this guy. So it's 25 at 10. So 2.59 milliamps at an angle of 89.63. I'm going to save that in my calculator. Times 8K at an angle of negative 90. So the first voltage I get is 20.72 at an angle of negative 0.37 degrees. Then we're going to do it again. Current times 2.634K at an angle of negative 48.81 equals 6.82 volts. So I'm going to put that here, 6.82 at an angle of 40.82. So that's the voltage for that guy. Okay. Now we got to get the voltage for this guy. So the current times 500 at an angle of 90 is 1.30 at an angle of 179.63. Okay, so this voltage, and this voltage has to add up to where it came from, which is here. So let's add that up. Okay, so we have 20.72 at an angle of 0.37. Oh, it's negative 0.372. Negative 0.37 plus 6.82 at an angle of 40.82 plus this voltage 1.30 at an angle of 179.63. When we add them up, we pretty much get it. It's 24.96. Or you can actually do this. Here's 25 at an angle of 10. Close enough. So they all match. The reason why we verify our voltages before we go to the next step is so this way you don't bring up a mistake the whole way. So lastly, we're looking at this. How did we get this? We did the parallel combination. What's constant in a parallel is voltage. So this 6.82 at an angle of 40.82 is going up to this and this. And then we have to get their currents. And their currents should add up to where it came from, which is this guy. And that's 2.59 at 89.63. So let's bring up the 6.82. 6.82 at an angle of 40.82. And then 6.82 at an angle of 40.82. So this voltage is here. We're going to take voltage divided by this to get this current. Voltage divided by this to get this current. These two currents have to add up to where it came from, which is this guy. So let's do that. 6.82 at an angle of 40.82 divided by 4K is 1.71 milliamps. So 1.71 milliamps at an angle of 40.82. That's that current. Then we do the next one, 6.82 at an angle of 40.82 divided by 3.5K at an angle of -90 equals. So we should have gotten 1.95 milliamps at an angle of 130.82. We know that that's right because this and this have to add up to here. So let's do that last calculation. 1.71 milliamps at an angle of 40.82 plus 1.95 milliamps at an angle of 130.82 equals 2.59 at an angle of 89.57. Close enough. So now we have voltage and current for everything, right? So we have the voltage for here. Okay, the voltage for there we got here. It's 25 at 10. This is the current through this, right? And we got it down here. The voltage at this we got here. The voltage is this. The current is this. Here we got the voltage here. And you can bring all these back, right? And that's it. The last two voltages is here. So normally when I check your circuits, I'm checking for Z total and I'm checking for the voltage or current here. If that's right, you brought it back right. Okay. Talk to you guys later.